Hi. Last video we learned how to do implicit differentiation, and I gave a couple of examples, but I want to give a couple more today because it's a pretty hard topic. And also I'm hoping that you're not just doing this mechanically but really understanding what's behind implicit differentiation, so that later on when we get into applications you're going to understand this a lot better. So find the equation of the tangent line to the curve, and there's a curve, a representation of a curve that I think probably you don't know exactly what it looks like. But they were nice enough in the problem to give us the point on the curve that we're trying to find the tangent line in. So all we really need to do is find the slope. So in the xy coordinate system, the slope is always dy dx, the rate of change of y with respect to x, or y prime of x. So I think you agree with me that I do not want to solve that for y in terms of x. So I can't do it explicitly, I've got to do it implicit differentiation. So what does that mean? It means you just start taking derivatives with respect to x of everything in your relationship. Now, what do we have going on this side of the equal sign? We have x times the sine of 2y. So we've got to use the product rule. So we take the first function x times the derivative of the sine of y. Well, the derivative of the sine of y, or sine of 2y, is the cosine of 2y. We're doing the chain rule, times the derivative of 2y, and the derivative of 2y is going to be 2y prime, because we're taking the derivative with respect to x. So the derivative of y is dy dx, or y prime. Now we have to go plus the second function, the sine of 2y, times the derivative of x. Well, the derivative of x with respect to x is just 1. Now we have a equal, and now we have another product rule. We have y times the cosine of 2x. Well, the derivative of y, or the product rule would say y times the derivative of the cosine of 2x. The derivative of the cosine is minus the sine of 2x, but times the derivative of 2x, well, that's just going to be 2. Now we have plus the cosine of 2x, the second function, times the derivative of y, which is y prime. So we've done all our derivatives. Now, if we really needed to find the slope at a bunch of different points, we'd have to go through the algebra here and isolate all the y prime terms together and get this relationship that we could plug values of x and y into. But since we only need it at this one point, I would suggest that we just solve for y prime at this point by plugging it in right now. So x is what? X is pi over 4. We have the cosine of 2y. So we have pi over 4 for x. The cosine of 2y would be the cosine of pi, which is -1, times 2y prime, plus the sine of 2y. That's the sine of pi, which is 0. So I can just ignore that. That's 0. Equals. Well, now we have y, which is pi over 2, times -2 times the sine of pi over 2? Well, that's just negative 2 plus the cosine of 2x. That's the cosine of pi over 2, which again is 0. So this is making our life quite a bit easier. First of all, we can multiply both sides by negative 1. The 2 cancels with the 2. And we could really get rid of the pi's. We can divide both sides by pi. And we're left with what? 1/2 y prime equals 1. Or y prime equals 2. I think that was a smart way to do things. We got rid of a lot of the algebra we had to do because it turned out that 2 of those terms turned out to be 0. Now that I have the slope, can I write the tangent line? Use the point slope form. Y minus pi over 2 equals the slope times x minus pi over 4. And we found the tangent line on a very complicated relationship between x and y. And we had to be careful, but it wasn't all that bad. Okay, so the last one I'm going to do gives not quite as hard of a relationship between x and y, but I'm going to ask to find the second derivative. Now, I'll tell you right up front that we actually could do this one explicitly. With a little bit of algebra, I could solve for y, but it's going to be a pretty complicated function of x, and we have to take a second derivative. Not saying you couldn't do it, but let's try to do it implicitly because that's what we're practicing right now. So before you can get the second derivative, we've got to first get the first derivative. So implicitly, just start taking derivatives. What's the derivative of 3y squared? Well, the derivative of y squared is 2y, y prime. So we get 6y, y prime, minus the derivative of 2x cubed, which is 6x squared, equals the derivative of a constant, which is 0. Now I can divide everything through by 6, so I could just basically get rid of the 6, and then I get, and solve for y prime. Y prime, if I bring the x squared to the other side, is x squared over y. Well, they didn't ask me to do it, but I could find the slope at every point on this curve. But since we have to find the second derivative, I can just take the derivative of the first derivative with respect to x. And I have to use the quotient rule. So I can say y double prime, which is the same thing as d squared y over dx squared, depending on which form you want to write it. I have to do low y d high. The derivative of high is 2x minus high d low. The derivative of y is y prime with respect to x, all over low squared. Now, that actually could be used if you knew what x and y are. You could put the x and y in, and you could find out what y prime is from this. So you could, at any point, find what the second derivative is. But if you really want a nicer relationship that doesn't have the y prime in it, we could just, in place of the y prime, put in x squared over y. And then divide by y squared. But we really don't like to have complex fractions, fractions within fractions. So simplify this just a little bit, I can multiply the numerator and the denominator by y. And I get 2xy squared minus x to the fourth all over y cubed. And now I've got a nice relationship where if you gave me any point on this curve, I could just plug it in there and get the second derivative. So, implicitly, not too bad. Explicitly, I think it would be just slightly harder. But there will be some that you can't do anyway but implicitly. So, keep practicing. I know you can do these implicits. It just takes a little bit of practice. So, have a good day.